This is part 2 of our video on bivariate correlations, specifically Pearson's R and testing Pearson's R's for statistical significance using the 5 steps of hypothesis testing. In the last video, we left off with our table where we were beginning our calculation for Pearson's R, and we had calculated the different parts and pieces of the equation. We're going to plug in the parts and pieces that we calculated in the last video into our equation for Pearson's R. So the top of our equation is going to be negative 16 divided by the square root of 34 times 8.8. So those are the numbers that we calculated in the last video. Negative 16 is the sum of the x minus the mean times y minus the mean. 34 is the sum of x minus the mean squared, and 8.8 is the sum of y minus the mean squared. So we're going to have negative 16 over the square root of 299.2. So we're going to have negative 16 divided by 17.3. So 16 divided by negative 16 divided by 17.3 is going to give us 0.92 as our value for Pearson's R. So that is Pearson's R. So now what we want to do is we want to plug this into our equation for t. Our equation for t is the r that we just calculated times the square root of n minus 2 divided by 1 minus r squared. So our equation then is going to look like this. It's going to be 0.92 times the square root, and we had 5 respondents, so n is 5 minus 2, divided by 1 minus 0.92 squared. So we have 0.92 times the square root of 3 over 1 minus, let's see, 0.92 squared is 0.85, if we're, again, rounding to 2 decimal places. So we're going to have 0.92 times the square root of 3 over 0.15. And so 0.92 times the square root, 3 divided by 0.15 is 20. So 0.92 times the square root of 20 is 4.47. .55. So 3.55 is our value for t. So now we can take this and we can move on to step 3 in our 5 steps of hypothesis testing. So we need to calculate degrees of freedom. And the equation for degrees of freedom is n minus 2. So we are going to take our n minus 2, and for this one, n is 5 minus 2, so we have 3 degrees of freedom. Now we're going to look up the critical value in the t-table. This is the same t-table that we use for t-tests. And just like before, if the t-value is above the critical value, then we're going to reject the null hypothesis and we'll say that Pearson's R is significant. So let's see what our t-value, our critical value, is. So here we have a critical values of t table, and so we are going to go to 3 degrees of freedom. So we go degrees of freedom down to 3, and then we go over and we are looking for a two-tailed test just like we did before. So we want this bottom number two-tailed, and we're looking for 0.05 level of significance down to 3 degrees of freedom. So 3.182, this number here is our critical value. So this critical value is lower than our t of 3.5. So now we move to step 5, which is making decision and interpretation. We would interpret Pearson's R and the t-test this way. We would say that Pearson's R of negative 0.92 indicates a very strong negative correlation between age when first married and the number of children that one has. The later you marry, the fewer children you are likely to have. We reject the null hypothesis that there is no relationship between age when first married and number of kids. The relationship is statistically significant at the 0.05 level. So we've got a couple of things here that we have said that are important to include. So of course you need to include the Pearson's R value. You need to say whether it's strong or weak, and then whether it's negative or positive. Also make sure that you are going back to the original variables, and then we're also talking about whether we reject or fail to reject the null hypothesis, and we are restating that null hypothesis, and then we're also saying whether or not it is statistically significant at the 0.05 level. So all of those things should be included for a full and complete interpretation of Pearson's R. What would this look like in SPSS? This is an example, an age when first married and the number of children. This is actual data from the General Social Survey, and you can see here that we've got kind of a table that has a bunch of different numbers. So basically what we have here is we've got each variable going both directions, and so it's a matrix. It's called a correlation matrix. So we look at kind of where the variables line up. So you can see that you've got kind of a mirror image. Age when first married, and then age when first married. So of course those are going to have a correlation of 1. And then you have number of children, and number of children, and of course you have a correlation of 1. So then when you have age when first married by children, you can see that you've got that twice. It's in the table 2 times. It doesn't matter which one you look at, but here's the number. It's giving us negative 0.259, and then you'll notice that there are 2 little asterisks, or stars, after the 0.259. And if you look down here at the bottom of the table, there's a little key, and 2 stars says correlation is significant at the 0.01 level, 2-tailed. So 0.01 level is more stringent than the 0.05, and so this would be considered statistically significant for our purposes in the way that we've talked about statistical significance. So the way that we would interpret this is we would say that the correlation between the respondent's age when they first got married and the number of children that they have is negative, which indicates that as the age when the respondent first got married increases, the number of children that they have decreases. The relationship is moderate at negative 0.259 and statistically significant at the 0.01 level. So there we have kind of a complete interpretation of the SPSS output. Okay. There's one more part to Pearson's R, and it is something called R squared. It's the coefficient of determination. Now, R squared tells us how much of the variation in the dependent variable can be attributed to changes in the independent variable. So we calculate R squared by squaring the Pearson's R that we calculated. So let's say that Pearson's R was 0.97. We're going to square that number, and it gives us 0.94. And we can interpret this as a percentage. So we move the decimal place over twice, and we have this interpretation. The coefficient of determination, R squared, tells us that 94% of the variation in spouse's education is attributed to changes in the respondent's own education. R squared equals 0.94. So R squared, the coefficient of determination, tells you how much of the variation in y can be attributed to variation in variable x. And we'll talk more about this next week when we're talking about regression.